What's up, guys? It's your boy Lavisito, and this is Leetcode 3433. Count mentions per user. So let me just maximize this. I'm gonna read this real quick. You are given an integer number of users, and that's the total number of users. And you're also giving an event array. And here, first I'll actually show an example. So like this is your input, right? This is basically what you're getting in right here. You're getting this in, and your output. You're trying to. Well, first let me explain the events array. Your events array is either gonna look like this or like this, right? So a message event, you're given a message, a timestamp, and a mention string. And basically, the mention string can contain this string right here is gonna just contain IDs, so it's gonna look like this, right? It's gonna have your ID 0, ID 1, and note that that is like these IDs are gonna be in between 0 and this -1, right? So it's gonna be in between 0 and 1 inclusive, and that's actually a constraint, I think. Right here, yep, right here, that's the constraint. So yeah, this can be either 0 or 1, and same with here. So yeah, you have your mention string, your ID number that has to be in this range, yeah, and they give the range here. It can be multiple IDs separated by a single white space. And yeah, okay, this is actually what got me a wrong answer. This key detail right here, I'll go more into it. Why? All mentions all users, and here mentions all online users. And then an offline event is going to be looking like that, and it's just going to turn this ID, the user with this ID, offline, right, at this timestamp. And they'll automatically get back online at timestamp at I plus 60. And then, yeah, you're just going to return an array mentions where mentions I returns the number of mentions the user with ID I had across all message events. So basically, that's just going to be, it's going to be the number of times he's mentioned in this, and like this type plus this type plus this type, right? So you actually have to loop through all the messages and stuff, and you have to do kind of a simulation type of solution, or well, that's how I did it, at least. I don't know if you have to, but yeah, what I'm going to do is I'm going to just go through this example right here. So in fact, because here, let me show you guys what got me a wrong answer, like when I was doing this an hour ago or so. So yeah, I got a wrong answer at 9/17, December 12th, 2025. And so yeah, look, what I did was that I didn't pay attention to this line right here. That this mention string can mention online users, right? So here, and where is it? Right over here. Right over here, I didn't count this, right? And because I didn't count this, because this the user with ID 2, I put it in a set, and that was like a set of all offline users. And I checked, oh, it's offline, so this message doesn't come through. Well, the problem actually states that you can mention offline users. Very wacky architecture, but yeah, or just a wacky problem in general. But I don't know. Here, that's little nitty gritty details I'm not gonna go into, but I'm just gonna walk through this. So basically, you want to handle events as they happen, right? As they happen sequentially, so that you can see, you can accurately gauge your number of messages in a very easy manner. So what you do is, first you're going to sort this, right? You're going to sort this so you see what messages come in, who's offline at what time. So for example, here you will sort it first by here. Remember that by this line, yes, all users are initially online, but if a user goes offline or comes back online, their status changes process before handling any message event that occurs at the same timestamp, right? So because of this sentence right here, you're actually gonna sort by two stuff, right? You're gonna sort by the message type right here. Sort by this. Let me change the color. You're gonna sort by the message type. Or no, wait. First, you're gonna sort by the time, right? Because you have to handle whatever comes in and whatever. Then you do so by the type, and yeah, you can do this in any of your desired languages. But yeah, you have to sort this array by numerically for the timestamp, not lexicographically by the string. You have to do it numerically. So you have to convert this into an integer, and then you do it by, oh, if it's offline, it has higher priority because of this right here, because of that. So the way you would sort this is actually you get this first, or no, not, yeah, it will be this first, right? This will be index 1, this will be index 2, this will be index 3, and this will be index 4, right? So now I'm gonna go by that order, and I'm gonna have an array that I'm gonna store the return value in, right? Because that's what the problem asks for. It asks for it asks for the number of mentions, right? A mentions array. For each user with ID I across all message events. So okay, you encounter this, and you're just gonna add 1 to the user ID 0 and the user ID 1, right? So this right here is going to be, oh soup, wait, hold on, I'm sorry, soup. Okay, so this is gonna be 1 here. I'll just cross it out for now. I need to learn this software. But yeah, this is gonna be 1, and this is gonna be 1, right? Oh, sorry, and I added an extra entry. So here, let me just undo it like this. There we go. Okay, so this is gonna be 1 right here, and this is gonna be 1, right? So now you're done with this event, right? So you go to the next one. You just cross it out to show I'm done. So next one, you see, okay, it's an offline event. So you're gonna have some type of set, 2, right? So yeah, I threw this in an offline set, and I also tracked the offline times using a queue. So I mean, I guess I'll also put like because I did it with a tuple, right? So it has 2, the user will ID 2 at timestamp 5. So I did it, I think, in this format. So this is a queue, and this is a set. Yeah, I know. I kind of like did a bringing a bazooka to a sword fight thing where I used 30 different data structures. I don't think you had to do this for this problem, but yeah. So now you go here and you add that to offline set. Now you go here and you realize, oh, message 5 ID 2, you can't send that. So by logic explained earlier, so this becomes 1. Then you go here and you see it can send to all, so you just send it to all of them. And yeah. And also notice that if this were here, if this said, in fact, I'm gonna simulate what would happen if it was a here though. So if this were here, instead, HERE, I think that's how you spell that. Ooh, bad handwriting. Hold on. Okay. If this were here, then what you would do is first you would check for every ID. You would loop through every ID and you check, okay, is every ID, is this current ID in, for every ID, if the ID is inside this offline set, then you would just not add it, right? So if this were here, it would actually be 112. The return value would be 1 1, or no, 221, because you wouldn't add this, it would stay 1. Ignore this cross out. But yeah, essentially that's the problem. And also, you might ask, okay, why do I keep this offline queue? Because of this right here, to handle the case where do they have a test case for it? Let me check. Okay, they don't, but it's basically, or do they? Yeah, they do right here. So notice that this right here, for this, what I do is that for every event, I loop through every event sorted. I check if, it satisfies this stuff and whatnot, right? Given your offline set. Then I look at the timestamp of this and I see, okay, it's 71, right? Let me check to see if the first element that I added in here is going to have a timestamp of, right? If this element is basically checking if this element right here was added at a time like if it's back online. You're just checking if it's back online, right? And I'm just gonna walk through the code. So yeah, you have this. Wait, what's this for? I don't think I even used this variable, did I? Let me just do this. Yeah, I don't know why I have that variable there. But yeah, essentially, to handle all your edge cases and stuff, first you sort your events. Then yeah, this is my offline queue and set that I was explaining earlier. This is the return value. And so yeah, you loop for I in range of number of users. You just append 0 because everything defaults to 0, right? Because 0 means you get no messages. And then for every event, what you do, yeah, I unpack the values here. For every event in the sorted event array, you check your offline queue, right? And you check, is the timestamp of the current event happening? Is it already, because remember this array is sorted, so all the next events is going to have higher timestamps. So this inequality will hold for higher, but you check, is your timestamp less than the first element of my offline queue? Because remember the format of my offline queue was ID comma timestamp. Or no, it was timestamp. Sorry guys, it was timestamp comma ID. Yeah, look, timestamp comma ID. That's how I formatted it. And so you check, okay, is this timestamp plus 60? And if it is, you already know that user is back online automatically by the problem statement. So you just, or no, if it's less than, if this condition is met, then the user's still offline. So just break out of the loop, right? And notice that because it's a queue, it's a first in, first out. So every user after this in the queue is also going to follow this inequality. So you can just break here. And also notice, okay, you remove your element if more than 60 seconds have passed from this thing being offline, right? From this element being offline. So yeah, you just pop left and you remove it from your offline set so that it shows accurate data for that current timestamp. And then yeah, you do the logic I explained for here. Notice you check if your user's offline or not. For all, you just add everything plus 1. And yeah, just the logic I explained earlier is here. And you just return your return value. So that's about it. Thank you for watching. Blah, blah, blah. Whatever they say in the outro. Keep doing your Leetcode.